So last week when we started learning content information, really most of it was a review, but we talked a lot about the stork. And I want to kind of go back over the stork ideas. First, we call this stork concept the nature of science. And basically it's just that for years, teachers have been teaching science in a way that is not realistic to how it actually goes on. Now we'll be learning more and more and more about these concepts throughout the year, but there's four major ones that I want to make sure that you understand. The first one is that the scientific method is one of many methods that scientists use. It's not always done in order. And that there's a lot of different ways to do science, whether it's naturalistic observation or surveys. There's a lot of different ways that we can study science. The second one is that scientific ideas can never be proven. They can't be proven. You can find support for them, you can find support against them. But because science doesn't really have the answer to all the questions, we can't really prove something. We can only support for it, or we can support against it. The third one is kind of a two-pronged. It's all about observation and inference and laws and theories. Observation is what we see, hear, feel, experience in a laboratory situation. It's where our data comes from. Inference is the interpretation of that data. So if we are doing an experiment and we feel that the test tube or the flask gets cold, the observation is that the test tube is getting cold. The inference is that the reaction that's going on inside that test tube requires heat, and so it's pulling it from the surroundings, so now the surrounding flask feels really cold. Now that may seem a little complicated for you, and we'll talk more about that in the chemistry section, but the idea is the inference explains the observations, and the inferences are things that we cannot see, but they're based on long-standing information that we have of science or scientific knowledge in general. The other piece of this scientific puzzle is the idea of laws and theories. Contrary to popular belief, neither is more important. Laws aren't more important than theories. Theories are not more important than laws. Both of them are of equal importance in science. Laws explain an observation. There's something that we see. So the observation of gravity, the law of gravity, is that when we drop things, they're going to propel themselves towards the center of the earth. That, simply put, is a law. It's based on an observation. It is repeatedly over and over again true and observable. Theories, on the other hand, are based on inferences. So that's the explanation as to why the law of gravity exists, which has a lot to do with the size of masses and things of that nature. And we'll talk about that a little further in the year when we get to the physics section. For now, we're just in the reviewing science concepts. Anyway, so we have laws and we have theories. Theories almost never become laws, and we talked about the 2 times in all of history when that's taken place. So if your science fair teacher or your science teacher, the elementary teacher, told you that if you worked really hard, you would make a theory and your theory would become a law, they were mistaken. That's not how real science happens. In our next video, we'll talk about the parts of the experiment, and the experiment is probably one of the most popularly known, not necessarily the only, not necessarily the primary way that scientists investigate the world, but it is the way that most of you have heard of. So we'll do that in our next video.